In October 1944, the U.S. Navy submarine USS Tang, CES 306, entered the Luzon Strait under conditions that Fleet Submarine Force Doctrine explicitly labeled as marginal. Visibility fluctuated below 6 nautical miles. Sea state sat between Beaufort 3 and 4, enough to disrupt periscope stability at attack depth. Japanese convoy routing off Formosa followed coastal traffic separation rules that compressed merchant hulls, escorts, and patrol craft into narrow sea lanes protected by overlapping visual lookouts rather than continuous sonar coverage. Tang's assigned patrol box overlapped this corridor by less than 40 nautical miles. Fuel state allowed no prolonged pursuit. Battery endurance at 90 feet limited submerged operations to defined windows measured in minutes, not hours. From the outset, the patrol existed inside a stack of constraints. USS Tang was a Balao-class fleet submarine, pressure hull rated for 400 feet, driven by 4 Fairbanks Morse 38 D818 opposed piston diesel engines generating 5,400 shaft horsepower surfaced, feeding 2 main motors submerged at 2,740 horsepower. Her offensive system was centered on 10 21-inch torpedo tubes, 6 forward, 4 aft, supplied with Mark 18 electric torpedoes and residual Mark 14 steam torpedoes. By late 1944, Mark 18 reliability exceeded 85% under control conditions, but speed was capped at 29 knots and range at 4,000 yards. Every firing solution was therefore governed by geometry, not aggression. Commanding Officer Richard H. O'Kane had already absorbed the lessons of earlier patrols. Surface night attacks offered superior visibility and speed, but collapsed instantly if detection occurred. Submerged daylight attacks reduced detection probability, but imposed rigid periscope exposure limits measured in seconds. Doctrine emphasized caution, avoidance of dense escort screens, and disengagement once counter-detection thresholds were crossed. Tang did not disengage. On the night of October 23, 1944, Tang detected a Japanese convoy consisting of at least 3 medium cargo vessels, estimated 5,000 to 7,000 tons each, escorted by patrol craft rather than full destroyers. Radar contact was intermittent. Surface approach speed stabilized at 17 knots to preserve bow wave discipline. At 2,300 hours, Tang closed to inside 2,000 yards on a parallel course. This was already beyond conservative doctrine. The limiting factor was not courage. It was turning radius. At 18 knots, Tang required more than 700 yards to reverse course without cavitation that would betray her position. The first attack unfolded under a single overriding constraint: torpedo reload time. Forward tubes required approximately 15 minutes to flood, open outer doors, and achieve firing readiness after a salvo. O'Kane, therefore, selected a spread pattern optimized for immediate kills rather than sequential engagement. 2 Mark 18s were assigned per target. Gyro angles were minimal to reduce guidance error. Firing interval was set in seconds, not minutes. At 2,312 hours, for torpedoes left the forward tubes. 2 hits were confirmed within 90 seconds. A third vessel began emergency maneuvering. Escort reaction lagged. No sonar pings were detected in the first 2 minutes. This absence was not reassurance, it was warning. Japanese convoy escorts relied heavily on visual acquisition at night and reacted slowly underwater. But once alerted, depth charge patterns were short-range and immediate. Tang remained surfaced. What followed diverged completely from accepted submarine employment models. Instead of withdrawing to reload, Tang executed a high-speed surface repositioning maneuver inside the convoy's turning circle. This exploited a physical limitation of merchant hulls, their inability to reverse course rapidly without losing steerage. Tang's diesel engines were pushed above economical limits. Exhaust plume risk increased, but speed dominance was decisive. Between 23:15 and 00:30 hours, Tang conducted multiple surface attacks, alternating bow and stern tubes. Reloads were executed underway. Each reload cycle consumed minutes that were filled by evasive zigzags calculated to stay inside blind arcs. This was not improvisation. It was mathematical exploitation of reaction time. Escort vessels required visual confirmation before maneuver. At night, that confirmation window stretched long enough for Tang to act repeatedly. By 0100 hours, at least 4 merchant ships were either sinking or disabled. One escort attempted a ramming approach, but overshot due to relative velocity misjudgment. Still, the technical ceiling was closing. Battery charge was irrelevant. Fuel and reload limits were not. Tang's torpedo inventory was finite. The patrol's operational risk had crossed irreversible thresholds. The final engagement phase was dictated by a single physical constraint: minimum safe firing distance for stern tubes under surface conditions. To engage a remaining target astern, Tang had to maintain course stability long enough to fire accurately while exposed. At approximately 0150 hours, a stern-fired Mark 18 ran erratic. Its circular run was not immediately detected. At roughly 20 seconds after launch, the torpedo reacquired Tang's own acoustic signature. The interval between realization and impact was under 30 seconds. No evasive maneuver could overcome the torpedo's closing vector at that range. At 0152 hours, Tang was struck near the stern. The explosion breached the pressure hull. Flooding was immediate. The submarine sank in seconds. From a doctrinal perspective, the patrol should have ended earlier. From a technical perspective, it ended exactly where system limits dictated. Tang had destroyed a convoy not because she ignored risk, but because she calculated it differently, using speed, reload timing, turning geometry, and enemy reaction delays as weapons equal to torpedoes. The broader implication was unavoidable. Japanese convoy defenses in 1944 were optimized for predictable submarine behavior: submerged daylight attacks, cautious surface engagement, early withdrawal. Tang demonstrated that within those same environmental and mechanical constraints, an aggressive exploitation of time constants, reload cycles, human reaction delays, maneuvering limits, could collapse an entire defensive assumption stack. This was not recklessness. It was systems analysis conducted at night, at sea, under combat load. Doctrine labeled Tang's approach unsustainable. Engineering limits labeled it temporary. The convoy off Formosa proved that, within a narrow temporal window measured in minutes and seconds, temporary was enough. After the sinking, the implications propagated outward through layers that doctrine had never fully integrated. The immediate operational constraint was time compression. Tang's attack demonstrated that once a submarine commits to continuous surface engagement, the decisive factor minimizes to the overlap between torpedo reload cycles and escort reaction latency. Japanese convoy escorts in the Formosa sector relied on visual acquisition and short-range sound detection, with effective response times exceeding 90 seconds from first sighting to coordinated maneuver. Tang's surface speed advantage, sustained above 16 knots, collapsed that margin. Each additional minute on the surface increased detection probability, but each minute also enabled another reload cycle. The balance tipped not because the risk vanished, but because the kill rate exceeded the escort's ability to reset. This exposed a structural weakness in convoy defense design. Escorts were positioned to deter submerged approach vectors, not sustained surface penetration. Their turning circles, constrained by displacement and rudder response at night speeds, prevented rapid course correction once Tang inserted herself inside the convoy's lateral spacing. Merchant ships, operating at 8 to 10 knots, could neither scatter nor accelerate meaningfully. The convoy became a fixed geometry. Tang became the only variable. At the technical level, the patrol highlighted the dual-edged nature of the Mark 18 electric torpedo. Its wakeless profile and reduced detection signature enabled repeated close-range shots without immediate counterfire. At the same time, its acoustic homing system introduced a non-zero probability of circular run, especially after multiple firings that altered ambient noise conditions. Tang's final loss did not negate the system's effectiveness. It defined its boundary conditions. Beyond a certain density of engagements, the torpedo's own logic could no longer discriminate reliably between target and source. From a command perspective, Tang's patrol forced a reassessment of how success was measured. Traditional metrics emphasized tonnage sunk per patrol balanced against survivability. Tang inverted that equation. She achieved disproportionate destruction within a single engagement window, but exhausted her safety margins in the process. This was not failure by miscalculation. It was a consequence of operating at the edge of system tolerances. Fuel state, reload time, crew fatigue, and sensor saturation converged into a single narrowing corridor where continuation and termination became indistinguishable. Strategically, the Formosa action occurred during a phase when Japanese logistics were already strained by fuel shortages and fragmented convoy schedules. The destruction of multiple cargo vessels in one night amplified disruption far beyond their individual tonnage. Replacement hulls could not be crewed or fueled quickly. Escort coverage thinned elsewhere to compensate. Tang's patrol thus produced secondary effects that extended well beyond the moment of impact, even though the submarine herself did not return. For U.S. submarine force planners, the lesson was precise and uncomfortable. Aggressive surface tactics could deliver decisive results under specific conditions, but they consumed submarines as resources. Doctrine had been built to preserve platforms across multiple patrols. Tang demonstrated a mode of employment where a single patrol could reshape a local battle space at the cost of the platform itself. This forced a doctrinal tension, whether submarines were assets to be conserved or tools to be expended when conditions aligned. Technically, nothing in Tang's actions violated physics or engineering limits. Each decision followed from measurable parameters, speed ratios, reload intervals, visibility thresholds, and acoustic behavior. The collapse occurred when those parameters intersected without residual buffer. The patrol did not end because of an error in intent, but because the system reached a state where no further corrective action was possible within the remaining time. That distinction mattered. It reframed loss not as a moral judgment, but as a data point. Tang's destruction closed one loop in the feedback cycle between design, doctrine, and combat reality. What remained unresolved was how often such loops could be closed before the force itself was depleted. The night off Formosa thus became more than an engagement. It became a boundary test, a demonstration of how far a submarine could be pushed before its own weapons turned into constraints. And in that narrow window, measured in reload minutes and final seconds, USS Tang proved that doctrine does not fail gradually. It fails abruptly when reality moves faster than the assumptions designed to contain it. That abrupt failure point became the most valuable output of the patrol. Not the tonnage sunk, not the tactical audacity, the boundary itself. Tang's last engagement quantified, with unusual clarity, how submarine warfare behaved when pushed beyond conservative envelopes. The decisive constraint was not enemy strength, but system saturation. Sensors, weapons, propulsion, crew decision cycles, and enemy reaction times all converged into a compressed interval where additional success could only be purchased with irreversible risk. At the fleet level, this forced planners to reconsider how submarines interacted with convoy defense systems rather than individual ships. Japanese convoy doctrine assumed submarines would disengage after an initial attack, allowing escorts to re-establish perimeter control. Tang violated that assumption repeatedly. By remaining on the surface and re-entering the convoy geometry, she transformed a linear defensive system into a static one. Once static, its vulnerabilities multiplied. Every escort maneuver created gaps elsewhere. Every visual search narrowed focus and reduced overall coverage. Tang's continued presence amplified these effects until the convoy's defensive logic collapsed under its own structure. The technical anchor in this phase was human reaction latency. Escort crews required time to identify, classify, and act. At night, under stress, that latency expanded. Tang's surface attacks exploited this expansion deliberately. Each firing sequence occurred before the previous threat had been fully processed. This was not faster than human warfare in a modern sense, but it approached that threshold. The patrol demonstrated that when engagement tempo exceeds human coordination capacity, even well-designed systems degrade unpredictably. Inside Tang, pressure accumulated differently. Reload crews worked under diminishing margins. Each torpedo loaded reduced inventory and increased dependency on the remaining weapons. Battery state became secondary to crew endurance and situational awareness. Periscope use dropped to minimal exposure windows measured in seconds, forcing reliance on dead reckoning and visual estimation. Navigation accuracy narrowed. The margin for misalignment shrank with each maneuver. The final torpedo's circular run was not an anomaly detached from the preceding events. It was a product of cumulative conditions, altered acoustic environment from multiple explosions, increased machinery noise from sustained high-speed operation, and the inherent limitations of early homing logic. The system behaved within its design tolerances, but those tolerances had been eroded by sustained stress. When the torpedo reacquired Tang, it did so because at that moment, Tang had become the most acoustically dominant object in its field. This reframed loss as a predictable outcome rather than a random failure. The patrol reached a state where the probability distribution no longer favored survival. That state was entered knowingly, step by step, as each prior success narrowed the remaining escape corridor. Tang did not cross an invisible line by mistake. She approached it deliberately because the operational payoff continued to outweigh the immediate cost, until it did not. In subsequent analyses, this patrol informed a subtle shift in U.S. submarine employment. Aggressive surface tactics were retained but bounded. Engagement tempo limits were introduced implicitly rather than formally. Commanders were encouraged to exploit reaction delays but withdraw before system saturation set in. The goal became to harvest advantage without exhausting the platform. Tang provided the data needed to draw that line, even though she herself did not survive to operate within it. At a strategic scale, the Formosa convoy action illustrated how local superiority could be manufactured temporarily through timing rather than numbers. Tang did not outgun the convoy. She outpaced its decision loops. This insight echoed across other domains of the war, from air combat to amphibious operations, where control of tempo increasingly outweighed sheer force concentration. Yet the unresolved tension remained. Submarines were both scarce and decisive. Each loss reduced long-term capacity, but cautious employment risked missing fleeting opportunities. Tang's patrol embodied that dilemma in its purest form. It showed what maximum exploitation looked like and what it cost. By late 1944, the U.S. Navy possessed enough submarines to absorb such losses without strategic collapse, but not enough to ignore them. Tang's destruction therefore became both a warning and a benchmark. It marked the outer edge of effective aggression. Beyond it lay only diminishing returns. The convoy off Formosa was destroyed within hours. The doctrinal shockwaves lasted far longer. They reshaped how risk, tempo, and system limits were understood in undersea warfare. And they underscored a truth that doctrine often resists. When systems are driven to their limits, success and failure can become indistinguishable until the final seconds decide which one history records. The patrol of USS Tang off Formosa in October 1944 occupies a distinct place in the evolution of undersea warfare because it revealed, with unusual precision, how modern naval conflict was no longer governed primarily by strength, protection, or even tactical surprise, but by the management of limits. Tang did not challenge Japanese convoy defenses by violating known physical laws or inventing new weapons. She exposed the gap between how systems were expected to behave and how they actually behaved when pushed to their operational edge. Historically, this episode sits at the convergence of two trajectories. One was the maturation of U.S. submarine forces, which by 1944 had accumulated enough operational experience to move beyond rigid doctrine and experiment deliberately with tempo, exposure, and calculated risk. The other was the erosion of Japanese maritime logistics, which increasingly relied on standardized convoy procedures optimized for predictability rather than resilience. Tang intersected these trajectories at exactly the moment when local failure could cascade into systemic disruption. What makes the episode enduring is not the convoy's destruction, but the clarity with which cause and effect align. The outcome followed directly from measurable constraints: reload times, speed ratios, human reaction latency, acoustic discrimination limits, and finite weapon inventories. None of these factors were hidden. All were known individually. What doctrine failed to fully integrate was how they interacted when compressed into a single engagement window measured in minutes and seconds. Tang did not exploit ignorance. She exploited interaction. At the strategic level, the patrol reinforced a broader shift already underway in 1944. Naval power was becoming less about platform survivability over time and more about extracting decisive effect before the system collapsed. Aircraft carriers, submarines, and amphibious forces were increasingly employed with an understanding that exposure was unavoidable, but timing could be decisive. Tang's patrol demonstrated that a single unit operating at peak tempo could generate effects disproportionate to its size, even if that tempo could not be sustained indefinitely. The loss of Tang also clarified a boundary that doctrine alone could not define. Aggression had value. Excess aggression had cost. The difference between the two was not philosophical. It was technical. It lay in the point where cumulative stress degraded system behavior faster than commanders could adapt. Tang crossed that point knowingly because the operational payoff remained tangible until the final moments. Her loss transformed that calculation from an abstract risk into empirical data. In the years that followed, undersea warfare would continue to evolve toward greater automation, improved sensors, and more reliable weapons. Yet the fundamental lesson remained unchanged. Systems do not fail gradually when pushed beyond their design envelope. They fail abruptly, often without warning, when interacting constraints converge. Tang's final patrol made that truth visible in a way few engagements ever do. In historical scale, USS Tang was neither the largest submarine nor the most heavily armed. Her significance lies in how completely her final patrol mapped the outer limits of effective submarine aggression in the Second World War. It showed how doctrine can be outrun by reality, how success can accumulate faster than safety margins, and how the final outcome is often decided not by intent or courage, but by seconds, cycles, and constraints. That is why Tang's story endures, not as a tale of recklessness, and not as a caution against aggression, but as a precise demonstration of how modern war is shaped when systems are driven to their absolute edge, and what happens when there is no margin left.